In the late 1950s, strategic thinking ran to high-altitude airplanes for survival. We designed our airplanes that way. The B-52 was designed to operate up to 50,000 feet. For reconnaissance, there was the U-2. There was in development the XB-70 with its 2,000 mile-per-hour speed and a ceiling of over 70,000 feet. Invincible, we thought. Then came the Gary Powers shoot-down in 1960. And the U-2 brought down over Cuba during the missile crisis of 1962. High-altitude penetration was no longer the way to go. We, therefore, modified the B-52s with new avionics and developed low-level tactics, and at the same time, we launched a high-priority study labeled Advanced Manned Strategic Aircraft. This study concluded that to defeat the Soviet radar and surface-to-air missile threats, our bombers would have to fly fast and at extremely low altitudes. Out of this study in the late 60s came the B-1, or more precisely, the B-1A, which first flew in late 1974. While the procurement of the B-1A and its introduction into the strategic force was canceled in 1977, 4 of these airplanes were built and a flight test program continued. This advanced strategic system has achieved an outstanding flight test record of nearly 2,000 hours demonstrating the systems and concepts which comprise its superior capabilities. In 1982, when the B-1 program was regenerated by the President and the Congress, it inherited an extensive amount of test data which provided the technical impetus for the development of the B-1B. The B-1B, with all its improvements, is scheduled to be in full force of 100 aircraft by 1988. In view of our strategic missiles and submarine capabilities, why do we need a manned bomber? And why the B-1B? Our nation's posture of deterrence has long relied on what we call the triad of strategic weapons. The intercontinental ballistic missiles, 1,000 of them in hardened shelters, provide an adversary with an enormous problem to neutralize. Our submarine force, securely hidden under the sea, provides sea-launched ballistic missiles which further complicate the enemy's defensive problem. The manned bomber, which can employ a variety of tactics under positive control, offers the most flexible of the 3 elements of the triad. Together, these forces dilute the Soviets' defensive efforts. They cannot concentrate their resources on 1 or 2 predictable systems, but must always consider the 3rd and less predictable system. The manned bomber is highly versatile. It flies daily. It can be seen by citizens of this country who are reassured by its presence. It can be seen by potential adversaries when used as a diplomatic tool to demonstrate national resolve. This is Plattsburgh Air Force Base in New York. The airplane is the medium-range FB-111. Periodically, the Strategic Air Command exercises its forces to train its crews, of course, but also to give visibility to our strategic forces. Bombers can be dispersed to satellite bases and postured as a very visible increase in national readiness in times of crisis. And most effectively, the manned bomber can be launched under positive control, airborne, on the way to a target, but recallable at the last minute through an elaborate command and control system. What you've seen done here by the FB-111 can be done in spades by the B-1. Designed for fast alert response, the time from klaxon horn to being airborne is a very few minutes. The first crew member to the aircraft starts the auxiliary power units. Systems are powered up by the time the 4-man crew is at its stations. Fewer ground support personnel are required to get the system launched. It's reactive. The B-1A has provided answers to a lot of questions in its flight tests. It has flown new offensive and defensive avionics systems. Design features are being incorporated which will improve its prime asset, penetrability. A variety of electronic countermeasures will make it possible to defeat the enemy's efforts to acquire and track this airplane. Other systems are designed to defeat other threats, such as infrared seekers. Its low-level, high-speed performance provides great problems for an enemy's defenses. It is a capable penetrator. Phased array radar technology is used in both its defensive electronic countermeasures and its combined attack and terrain following radar systems. Much of the technology has derived from the highly successful F-16 phased array radar system. The ALQ-161 defensive avionics system was originally designed for the B-1A. The protracted flight test program has resulted in improvements which make it much more effective than anticipated in the early stages of development. Its reprogrammable design will permit quick adaptation to changing threats. One of the most significant improvements from the B-1A to the B-1B will be its improved capability to penetrate Soviet defenses. The great reduction of the radar cross-section of the airplane. By using radar-absorbing materials and reducing reflective surfaces, particularly the engine inlet area, coupled with additional physical and electronic changes in the radar signature of the B-1B, the airplane is much more difficult to detect on radar. The B-1B radar image is 10 times smaller than that of the B-1A, which was already much smaller than the B-52. Graphically, it looks like this. The B-52 signature, the B-1B. Add to this cross-section the terrain masking provided by the low-level flight system, traveling fast, just under the speed of sound, and you can see why the B-1B is called a penetrator. What can the B-1 deliver in the way of munitions? Here is another area of superiority. Its maximum gross weight will be 477,000 pounds. 125,000 of that will be deliverable payload, 75,000 pounds in its weapons bays, and an additional 50,000 pounds on external hardpoints under the fuselage. The 3 weapons bays can accommodate 8 gravity nuclear bombs each, or 3 rotary launchers for the short-range attack missile, SRAM. The bulkhead between the forward weapons bays can be moved to accommodate the longer air-launched cruise missile, 8 of them on a rotary launcher. The B-1B will carry external stores. In fact, Alchems can be carried on fuselage hardpoints, with the aft weapons bays still available for gravity bombs or SRAM. What a challenge to an enemy's area and terminal defenses. Extensive testing on the B-1A airframe has provided confidence in the accuracy and dependability of the offensive avionics and the separation qualities of the ordnance plan. We learned to give flexibility to our strategic bombers when we used the B-52 as a conventional bomber in Vietnam, with effective results. The B-1B can carry clips of 28 Mark 82 500-pound bombs in each of its 3 weapons bays. That's a total of 84 weapons internally. How Jimmy Doolittle could have used the B-1 when he planned his 30 seconds over Tokyo. It took a carrier task force supporting 16 B-25s with 80 crew members to carry some 64 500-pound bombs. That's 20 fewer bombs than the internal load of 1 B-1B. With all its technology, the B-1B is not an inexpensive plane to build. However, 1 B-1B with a crew of 4 could have departed the continental United States, dropped its 84 bombs, and been back in the States non-stop for supper. We've come a long way in less than half a century. The B-1B has a global range with aerial refueling. Coupled with its accurate navigation system and large weapons loads, the B-1B is suited to the maritime support mission, such as reconnaissance of strategic shipping lanes and the airlaying of mines. This versatile and long-range airplane is on the front burner now. With component testing on the available B-1A airframes, the Air Force has compressed the time needed to achieve operational capability. The new assembly plant at Palmdale, California, will achieve a schedule of 1 airplane per week when it reaches peak production. This will permit the first SAC unit to obtain initial operational capability in late 1986. All 100 planes are to be in the inventory by 1988. The Air Force, acting as the prime contractor in the development of the B-1B, coordinates the contribution of 4 associate contractors. Rockwell for airframe and final assembly. General Electric for engines. Boeing for offensive avionics. And AIL, a division of Eaton, for defensive systems. There are also some 5,200 subcontractors and suppliers in 48 states contributing to the effort. In all, some 60,000 jobs are directly related to the B-1B. This is the B-1B. Not exceptionally different in appearance from what we've seen already in this film. Note the engine intake, the most obvious of all the variances, one which permits the great reduction in the airplane's radar cross-section. There are windows in the rear crew area, one on each side. It has individual ejection seats rather than the crew capsule system of the B-1A. This is truly an advanced manned strategic aircraft that embodies the product of years of test and development. It is a long-range strategic nuclear delivery aircraft with tremendous penetration capability. Also, it is designed to handle conventional operations in support of theater commanders, rapidly and with great survivability. With sophisticated navigational systems and long range and endurance, the plane is able to fill the maritime support role. But most important is its visibility as a tool of national policy and resolve, to show the colors and to convince friend and foe alike that this nation is ready and equipped to fulfill its obligation to defend freedom anywhere on this globe.